Hello folks, this was a live stream on a little bit of short notice, so I'm glad you're all here. So today we're going to go through linear regression, specifically Bayesian linear regression with Bambi and PyMC v4. And I've actually not used the two of these together in a work setting, let's say. I've been using them in development, helping get them out there. Ooh, it's a little... Let's get this one out. And yeah, now I'll get to try it out just like a regular user. So let's just let's jump into it. So I was debating whether I should set it up before the live stream, but I decided it'd actually be cool to set it up with you all so you can see the full process. So let's go ahead and do that. Let us get to see where we are. All right. All right. Cool, we have a repository directory, so let us do this. Let me create a notepad. Oh, we don't have a mouse pad. I'll just type it in the chat for now. Thanks, Ari. All right, so what we're gonna do is we're gonna create a repository. So let's do that on GitHub. I'll just start from the beginning. Hopefully I'm logged in. Oh no, I gotta sign in. Okay, I'm a little farther back than I thought, so let me sign in. I'm gonna flip to a different screen real quick to input my password. One second here, folks. All right, one sec. Oh, I have my two-factor setup, which I don't have the key for right now. So give me another second. Sorry about that. All right, and we are back. So let's create a new repository where we have everything that we're gonna do. We're gonna call this Bambi Livestream. Get a Bambi v4 model working. Make this public, create the repository. Let me throw this in the chat for you fine folks right here. And let us create a README. Let's see. So goals. Get a PyMC v4 environment with Bambi. We're going to recreate an example from a particular book called Causal Inference Mixtape, which I'll show you in a second. And then we are going to, obviously, we're going to push the results up here. All right, so this is the specific goal of this live stream. Let me commit this. So let's go through and get each one of these done. Actually, let me change these to checkboxes so we can do it as we're streaming. I think I can do this. Let's try this out. Something new. Yes, it looks like I can. All right. I can't check them. All right. Well, we have our goals. So let's start with step one. Well, let me actually show you Causal Inference Mixtape first. So it is this book from Scott Cunningham. It's actually a really, really good book. I've been reading at least the first 2 chapters so far. Shameless self-plug, we have a book club going on where we are going through this book, and I've enjoyed it. And what I want to do specifically in this live stream is I want to redo, where is it? One of these examples, this one. One of these examples in Bambi. And so this particular book uses the frequentious methods of fitting linear regressions, and what we would like to do is use the Bayesian methods, which is why we're going to use Bambi. So we'll just go ahead and do that. First things first, let us get an environment set up. So to do this, let me clone my repo real quick, just so we have that. Okay, clone this. Man, I have not used this VM very much. Alright, well, if you don't have Git set up, that's how you get Git set up. Alright. Is this repository public? Yeah, it is. Let's try over HTTPS. There we go. Now we have our repo, and we have our README. So I'm gonna use conda, let's make sure I have that. I do. So we're gonna do conda create minus F. We're gonna call this Bambi Livestream. And I'm gonna use Python 3.9. Conda create, I always forget this. Conda create minus N Bambi Livestream. And so there we have it. We have a conda environment. We are going to copy and paste this environment. And what happens is this changes. So now we went from base to our Bambi Livestream. So now we need to install all of our different packages. So we need to install, let's do the easy ones first. We need to install, let's see, Jupyter, because we need that. We're gonna install matplotlib. And for now, let's start with that. Let's let those get into our environment real quick. MKL is a big package. It takes a while. It is a large one. All right, let's go look at PyMC and Bambi now. So we go to PyMC GitHub, and I want to show you exactly where the installation instructions for PyMC are at. So installation on Linux. What we want to do is we want to install the latest version from Conda Forge. So we're going to use these install instructions. This creates a PyMC4 environment, which is not exactly what I want. So we need to go back in. I need to get back to the team and fix this. But let's actually just use pip then. Let's do pip install PyMC. We get 4.0.0 here. And then let's go ahead and install Bambi as well. And so let me show you Bambi. Hello folks, I see we have a lot of people on the live stream today actually. This is actually very, very exciting. So Bambi, Bayesian models in Bayesian model interface. Let's go ahead. I actually forgot whether the newest version runs on PyMC4 or not. So what we're gonna do is just install this from the bleeding edge. That way we know for sure it does. This might take a while, sometimes these commands. Lars had the same problem with the environment. Then I just Conda install PyMC4. Yeah, Lars, we need to fix those install instructions. Really sorry about that that challenge. That is something we can make better for our users. Thanks for letting me know. Okay, we've got Bambi, we've got PyMC. So what I'm gonna do is I'm gonna fire up a Jupyter Notebook. Oh man, lots of challenges today. Let's try Jupyter Lab instead. Alright, guess we need to install Jupyter Lab, so let me go ahead and do that. Lots of installations. Alright. Wow. I've never run into this issue before, but of course I would run into it on a live stream. That's how these things always work out. Alright, let's try doing this in, it might be the file permission, so we'll try. Alright, there we go. So, brand new VM. What it's happening is that I think the OS is preventing file reads from the browser, which is actually a good thing security-wise because you don't want arbitrary websites to read your files most of the time. But in my case, I do want this particular website to open a file handle, but it's okay. We'll do things over TCP/IP. All right, so let's go ahead and test things out. Bambi Livestream. So import PyMC as PM. And let me know, folks, if this is actually working for you. If this is larger, I'll make it a little larger. I think that's better. We can get rid of this box too. Okay, great. We have our versions in here. Let's double check what they are. PM.version. Okay, great. We've got our environment set up. We're ready to go. So let me put our checklist in here too. What we need to do is load the data. Well, let's run a test model first so you can see. So you can see what Bambi looks like before we then try and load the data from causal inf mixtape and then run the regression that is shown in the book. The reason I want to run the test model first is if you watch me loading data forever, that's really boring. I think it'll be much more exciting to see something first before we get into me trying to figure out this new data set. So let's run a regression on the Palmer Penguin data set. If you are unfamiliar with the Palmer Penguin data set, you are going to become familiar with it very quickly here. So let me grab that first. So what we're going to do is we're going to get the Palmer Penguins from Palmer Penguin CSV. All right, here we go. This is exactly what I was looking for. So this is a really good data set for a lot of challenges. I think you saw real quick that it is available here, and it is quite nice for a whole bunch of data modeling tasks. So you can see that it's got groups, it's got a bunch of covariates, it can do clustering, it can do regression. So if you're looking for a data set to quickly try things out on, whether you're doing neural networks or machine learning or Bayesian analysis like I am right now, super recommend. So let's load this up into our notebook. Let's actually name this notebook. We don't want to commit the sin of having an untitled notebook. Let's import pandas. And folks, if there's anything you want to see in particular, let me know. Let me flip this over. This live stream is for you as much as it is for me. So let me know what you want to see or what you're interested in. Ask questions in the chat, make requests in the chat. I'll try and accommodate as much as I can. I really appreciate you being here. All right, let's get back to pandas. All right, so now we can do df equals pd.read CSV, and we can put in the URL. This is a super handy way to get data sets into pandas really quickly, or into Python really quickly. It's one of my favorite tricks when I get the parentheses matching to work. Oof. All right. Try this way. All right. Okay. We have our URL here. df equals pd.read CSV URL. And we got it. There you go. Here's our data set. It's looking pretty good. Let's go ahead and fire up Bambi. So let's do one where we regress let's say build length by build depth. Let's just start with this one first. So Bambi is really, really nice. Let's go to its documentation. As you can, this is literally all you need to do. It's really, really cool. So let's just copy and paste this, and we're gonna do df, and we're gonna do build length, and we are build length build depth millimeters, and let us run this. So we get our first warning. Bambi doesn't do imputation automatically, which is actually, I find that to be a nice thing. It's one thing I enjoy about this library is that I think it, actually, I know it strikes the right balance between being automatic and quick for you, but telling you where things may go wrong or where you should pay a little bit more attention. So let us go through and let's just do a complete case analysis. I'm actually going to copy the code straight out of my book because I wrote it there. So BayesianComputationBook.com. I'll throw that in here as well. We used the Palmer Penguins data set quite a bit. So I'm just going to copy this code out. Here we go. And I'm going to throw it into this notebook here so we can do what's called complete case analysis. And then yeah, this is fine. We're using build depth as well, so let's throw that in here. Let's rename this penguins. All right, let's try this again. Ooh, oh, because I have df. Renaming variables. Okay. Key error, build length. Names, man, they're the hardest thing. All right, and here we go. This is already sampling, which is really, really cool. Now, it looks like it's gonna take a bit. Well, I wanna point out, it's a lot faster on my actual desktop. I'm currently using a virtual machine and it's only got one core allocated to it. So it's actually, the virtual machine is quite underpowered, and I'm actually surprised it's sampling this fast. On my actual desktop, sampling like this would take under 5 seconds or so. It's not the fanciest desktop, it's a little, about 3 or 4 years old, but very, very cool that you can get full Bayesian results with MCMC this quickly these days. It is awesome. So let's look at the fitted model. And here is our inference data object. So here's our fit, here's our model, let's throw that in, oops. So here's our model from Bambi. It's got a really, really nice summary function, like a super good summary function for the model. You have your formula, you have the identity, the observations, you get a nice summary of what is happening here. So I love that. And then you also get the full inference data object from RVs. So let's go ahead and import RVs and just take a look. Do az dot plot trace fitted kind equals, I think it's rank bars. Oh, I always forget. Oh, here we go. Rank. Even I, as a developer, forget all the arguments. All right. So Lars is asking, why did we decide to use Bambi instead of full PyMC? Honestly, just because I decided to use Bambi in this particular live stream. I wanted to best capture, well, that's one reason, but the better reason is I'm running a book club. Again, selfish self-plug. Let me self-plug this a little bit more. I'm running a book club with all the details are right here. And we are reading Causal Inference Mixtape. So reading this book, and this particular book happens to be using frequentist analysis. There's nothing wrong with that. It's not a dig. I'm just stating the fact that they use, the author uses a frequentist style analysis. And in his book, when you look at the code, it's written using sort of the, what I call it, the formula syntax or formula syntax. So we're gonna find his code. Sorry. Here, this is the static code. Okay, here we go. So he is using the, is this it? No, this is cluster generation. So let me find the code for you. Oh no. Oh, and I'm not even showing my screen. Oh, hold on. All right, sorry about that. All right. What he's using is this syntax. He's using the linear, well, the book has the linear model syntax like this, where it's price, length, weight, headroom, so on. And it's actually the same in Python, where they're using the ordinary least squares regressor from stats models. So for the book club purposes, I thought Bambi would be a better fit because we can declare our models using this particular formula syntax rather than having to write out a full Bayesian model with priors and everything like that. So I hope that answered your question, Lars. Let me know if it didn't. I'll try answering it again. But let us jump back to Bambi super quick. Let's find those things. All right, here you go. We end up with our trace plot, which is cool. And then let's plot our posterior. And that's it, we got it. This is really cool. So really neat that Bambi really only requires you to do a very little bit of code declaration. Here's my dependent variable, here's my independent. I run a fit, and within a couple of lines of code, I already get my solid results. Really, really neat. All right, I see a couple comments in the chat. Let me check that. Paulo asks, I was gonna ask a similar question. I've never used Bambi myself. Is there a subset of problems for which you default Bambi over getting the nitty-gritty of PyMC? Or maybe so, are there any problems where you don't even think about Bambi because its atomicity makes it harder to debug? Paulo, this is an excellent question. So let me go back to full webcam. So if there's problems that are just going to be a linear regression of some sort, I use Bambi to start out with. I think it's quick and fast to just get in and start getting results. The other thing you asked is, what did you say? Because it's atomicity makes it harder to debug. So I actually don't think Bambi makes anything harder to debug. I actually think Tomas and the team have done a really good job applying a very, very simple interface, but don't hide any of the internals underneath. So let me show you an example here real quick. You might be wondering, well, what is going on with this model? What is happening underneath, under the hood? Let me go back to my virtual window. Bambi actually can output the full model graph for you. So let me show you that functionality real quick. Let's go to the docs. I gotta find this because it is so cool. Let me show you this result. All right, so it's model.graph. I'm gonna throw this in right here. I gotta install Graphis. Okay, give me 1 sec. Let's get Graphis in here because this is really cool and I really want to show it to you. We're gonna have to exit out of Jupyter Lab though. Oh man, all right. Should not have exited so fast. Let's grab Graphis. All right, while the Graphis is installing, let me check the chat. Is it also how you would, can I explain how to interpret the plots from Arby's? Awesome. And then Surya says Wilkinson formulae are more concise and nice to start with than PM.model. Yeah, I agree. The formulas are nicer to start with, and you can just get going. A comparison between PM.model and Bambi would be super cool. If we have time, let me do that as well. I want to show you that. Okay, so let's add that to the to-dos. Let's go to the live stream and let's say, otherwise I'll forget. Additional to-dos. Show the difference between fully declared PyMC model, and then there was something else. Explain Arby's plots. So let me go ahead and do that. Okay, we have those written down. By now, we should get this installed, because the other thing is I want to show you the model graph. I think the model graph is one of the coolest features of PyMC. And I think if you haven't seen one, I think your mind's gonna be blown. I'm just gonna say it. I think it's so awesome. So let's get back in here. Oh, I got this issue again. So let's grab my URL, get back over here. All right, so let's go through and we'll copy our to-dos from here as well, so we can refer to them. The formatting can work as well as I'd like, but the one thing I don't like about Jupyter Lab is the Vim integration. Okay, we got all of our goals, we're good here. Let's run everything. The model is gonna sample again. So quick overview, if you just joined, we're loading in the Penguins data set. We're grabbing the complete cases. So what's called complete case analysis. Our model is sampling. I want to point out again, I'm running this on an underpowered virtual machine. So the fact it's running this fast is incredible to me. On my actual desktop, it would run within 5 seconds. But let's give that just a moment here. And again, I have to say, thank you so much for being here on a Sunday morning, afternoon, evening, wherever you folks are at. Actually, do let me know where you folks are at. I'm really curious where everyone is located. All right, we've got our MCMC sampling completed. We'll take a moment for everything to settle in memory. Okay. Oh my gosh, I still don't have it. So frustrating. Okay, I thought I fixed this. Let's copy this. Let's open a new tab. trying to activate Bambi Livestream. Let's try this again. Environment issues, huh? I was debating installing the environment from scratch before the live stream, but I figured I should do it during the live stream because then folks can see everything and not just the working code. You know, installing environment is a whole process you need to do to get this stuff running. So let's restart the kernel and run this again. All right, and we'll wait another couple of minutes here. So Paulo asks a really good question. Can we trust Bambi is picking the priors correct? The short answer, well, the short answer is maybe, and the long answer is no. You should always take the time to think through your own priors and what they mean. So Bambi has an automatic prior selection process that is from published literature, so it's quite principled and it's pretty good. But if you're doing serious analysis, I would go through and double check all your priors and ensure that it's all correct. To the earlier question, I think that you asked as well, Paulo, when would I use Bambi? It's when I want to get results and start moving pretty quickly without having to spend a lot of time building a linear model. So I really like Bambi because it helps me just get started quickly. I can go in and I can get results and I can get moving. And then if I start realizing I need a larger model, like a full PyMC model, or I need to set my own priors, I could set my own priors in Bambi, or I can just write a full-blown PyMC model. So to answer your question, once again, the Bambi priors are great, and if you're not too worried about your data or your problem, just go ahead and use them. But if you're doing something really important, maybe like solving cancer, or in my case, launching rockets or something, you really should get in there and check them out. Hope that got that question. And wow, everybody's from Germany. Hopefully it's not too late. Surya, India, that is quite late. I'm glad that you are spending the time here with me. Okay. This is what I wanted to show you. It's the model graph. So there was a question earlier of, is it harder to debug Bambi because it's automatic? And my answer is no, I don't think so. Because when I debug, I just look at the model graph here, and this helps me see all of the connections in my model, where all the random variables are hooked up to or how they relate. And then if there's any issues with the sampler or anything like that, PyMC makes it quite easy to interpret. Another question, how do we interpret the plots from RVs? So RVs has a lot of plots. Like, I'm gonna just show you the RVs gallery real quick. There are so many plots in RVs. We got ridge plots, and we've got quantile plots, and we got KDEs, and tons and tons and tons of stuff. So I'll give you three answers here. One is, well, we can read the docs. We write a lot about how to use these plots in our API reference. So we write some stuff here and we show you how different stuff works. And then if you want a longer explanation, I'm gonna continue to plug my book. I hope you don't mind. But in this book, we wrote a lot about how to understand and use a lot of these plots as well. So in here, we show how to interpret MCSC plots and trace plots and rank plots and autocorrelation plots. So chapter 2 will have a lot of examples for you. But if we go to our example here, let me talk through this, and there's a couple of things I can mention. What I am looking for in these plots is I am looking for a well-formed KDE plot here on each parameter. Because these happen to look like a normal distribution, or Gaussian, I'm confident in them. I just happen to know that this data set should be Gaussian because I've used it so many times. And also, if I look at the Palmer Penguin data set, let me find that real quick. we can take a look at the plots. If I take a look here, I can also sort of tell that there's nothing that's really bimodal going on. It should essentially be Gaussian, so checks out. The one that's a little bit trickier is the one here on the right. This is called a rank plot, and what this is diagnosing is the MCMC samples themselves. I won't go too much into the explanation in this live stream because it's a little involved if you don't know what MCMC is, but the summary is you're looking for these to be roughly uniform, which is why there's this reference line here. And most of the bars are pretty uniform, so I'm fine with the results here as well. So things tend to be good. So this is what's called a diagnostic plot. This is actually specifically an MCMC diagnostic plot. Let me add this here. And let me type in, we want this plot because it lets us know if we can trust the results of Markov chain Monte Carlo. So this is a diagnostic plot. And then I'm gonna call this a results plot. And this is actually the thing we want, right? We want the results of our analysis. So in this case, what I can tell is that for bill length, there seems to be a very small negative correlation between bill length. Let's see what we got here. I even forgot the regressors that I'm using. Bill depth and bill length. So as bill depth increases, it seems that the bill length decreases. And I gotta find you the picture. Here you go. Here's the picture, bill length and bill depth. So as the bill depth increases, the length seems to decrease. I didn't know that about penguins. I literally just learned that right now. But again, this is the power of regression. So let's run a bivariate regression. Oh, actually, you folks asked for a full PyMC model. So let's do that. I'm gonna copy one out of the book because I don't want to write it totally. So I'm gonna shamelessly go back to my same book. And I'm gonna copy out one of these. So this is a full regression right here. Let us grab this one. So let's say full PyMC model. So here's the complete model, and let me know if anyone would like me to talk through this. The live stream is a little delayed, a moment or two delayed, so I'll wait for the chat. But while we're doing that, I'll set up the Bambi model. And I gotta copy over a Delhi mask. I forgot about that. Adeli mask. I have to find that. There we go. I think we got it. Okay, I think I have all the code for this to run. The one downside of copying and pasting random code that you in the live stream. Okay, I think we have it. This is just subsetting the data, and then here's the full model. We actually don't need this block, so I will remove this for now. So in a full PyMC model, you'd have to declare all of your variables explicitly. So you'd have to say, this is my sigma random variable, this is my intercept random variable, This is my covariate random variable, and then you would construct the regression yourself. So you would say beta 0, which is our intercept, plus our slope times our covariate, and then you would declare your likelihood here, and you would plug in each value of your likelihood. So the mean of the line, the regression, and the sigma, and then your observed value. So let's just see if this runs. Always gotta fix things like this. Utterly flipper length, Man. All right. Okay. Oh man. Okay, so one thing about PyMC 4 is we still have some challenges with coercion. So for those who are wondering what happened there, I passed in a Panda series. Currently, the Panda series can't be directly passed into PyMC v4. It causes challenges. What am I trying to say? If I type in dot values, that converts that series into a NumPy array, and then things just work. All right, this is gonna take a really, really long time. Do I want to wait this long? Probably not. All right, folks. We're not gonna watch this sample for this long. It's gonna take forever, and it is late in other places. So just take it for now that this is the PyMC model. And then if we want to get the Bambi model for the same thing, we would type in Adderley mass that, and then we would do this, and then it would be exactly the same. So this is the equivalent Bambi model. And you can sort of tell that the PyMC model, you can definitely tell, the PyMC model has many more lines of code versus the Bambi model, which is this bit here. So I love Bambi that I can just use the quick syntax here, have a linear regression. It is so awesome. Don't need to make a lot of changes. All right, so I'm gonna leave this as a to-do for you folks. I'll upload this. I'll upload this later, so you guys can see. So you all can try it out yourself. I got a question. Can I show how to specify a prior in Bambi? Sure thing. Let us do that. Lars, I may have missed your question. Can you re-ask so I can get to it? The chat is quite long now. So we'll get to that as well. I'm sorry about that, by the way. Trying to keep everything in my head at the same time between code, references, and questions. So please re-ask. I will definitely get you to your question. Let me get the Bambi docs for now. So, let me find an example of priors. Okay. Kakui, I'm not going to do it right now because I tend to mess up the syntax a lot, but it's right here in the documentation. This is an example on a particular model where we're setting our prior. So it's Laplace prior. We set our parameters here, and then we create a dictionary, and then we can plug it in. I may get to that later, but let me just give you this reference for now. I hope that helps. Lars, can we tackle a case when we have bad posterior geometry and maybe need a simple reparameterization in Bambi? Lars, let's actually try this. Yes, actually this is an easy one. So let's do that. Let's do a bad bad posterior geometry one. Let me try and find a. Let me try and make a case for you up on the top of my head. How can I do this for you? All right, I'm sort of at a loss how to come up with an example on the spot. So let me do two things for you, Lars. Let me write future live stream. How to debug a Bambi model, which is an excellent question. To give you the quick overview right now verbally, what I would do to debug a Bambi model, or what would happen, is if we had bad posterior geometry, we would see a lot of divergences right here. And so that there would be many more, all the divergences, well, there were no divergences here, but there would be many divergences, and we would follow the same steps that we use in every Bayesian workflow. We would use Arby's plots to diagnose where the divergences are coming in. We would try and figure out how that's happening, and it would be no different than any other PyMC model. So in our book, I'm gonna keep going to my book, but I spent a long time writing this. So we have an example in this book of where we have a poor posterior geometry. We have Niel's funnel, and here's an example. We go through a whole thing about how you can find those divergent samples, fix them, reparameterize the model, and such. So I think what I'm going to say later is that we will do another live stream at some point where I will show you how to fix a model. Oh, I'm so bad at this live stream. Here is the book where we show divergent samples in a linear regression, and then how to fix them in a PyMC. So we'll do a future one where we do this. Oops. And I'll use a hierarchical example. It's a little bit longer, and I can never spell hierarchical example. So I hope you'll accept that answer for now. And I think Kaikui, I hope I'm saying your name right as well. I hope that the other reference I showed you is helpful. Setting a prior. Super shameless self plug, by the way, since we're talking about this. One is if you're super interested in this stuff, we know there's a lot of questions, so we're literally making a course on this right now. It's gonna have a ton of stuff in here, from all the questions you've asked to advanced regression and everything like that. So if you're interested, you can join the mailing list, and we'll have updates for you. These questions come up a lot. But for now, we're gonna jump back into the topic at hand. Okay, so we've covered Bambi, we've covered PyMC. Specifically for the book club, I need to get this regression running. So I want to, I need to do this because I have a book club to run, and people have been asking me these questions. So let me go ahead and run this regression. We may need to have to do the things that you folks had asked for, which is checking for bad posterior geometry and manually choosing priors. So if you stick around, we might honestly see that, because I've never run the regression for this particular data set. So let me go ahead and do that. Let us look at this file real quick. I do not know what a DTA file is, so a lot of this a lot of this might be just you watching me load this particular file format for a little bit here. Oh, we have a read stata function. That's pretty cool. All right, so let's just try that. Okay. Thank you for the questions, everybody, by the way. This makes this live stream much more engaging. I'll say real quick, if you have questions for me anytime, please feel free to reach out. However, you can leave comments below once this live stream is posted, or message me on Twitter. I'm very happy to engage with folks that are trying to learn. I find it quite wonderful, so thank you again. All right, so let's do the causal in Mixtape example. So we can see URL equals that, and then I'm gonna call this let's call the book URL. I'll call it cars equals pd.reads data. It's the first time I've read a stata file in my life, so let's see if this works. Oh wow, that was fast. Okay, well, that was easy. It was way easier than I thought it was going to be. Okay, so let's run a regression. We're going to run the same regression that they run in their book. So let me copy this. So what do? They do price by length. So actually, let us literally just copy the syntax from here and just put it right in. I mean, to folks that had asked why I was using Bambi, this is exactly why I'm using Bambi. This book uses this formula syntax, so I wanted to follow the book as faithfully as I could, and let's see. Again, I've never run this regression, so I have no idea what's gonna happen. Let's try it. And you can definitely tell I haven't run this. Key error, price, and we don't have, oh, there's an extra little scanner. Oh, okay, there we go. While this sampling, I can answer more questions, and oh man, I think next time I'm going to, I'll put more cores in my CPU, in the virtual CPU. Let's actually reduce the number of samples this is going to take, otherwise we'll be here forever. So let's find fit, model of fit. Okay, we're gonna reduce these. So let's just do. Oh, wow. Okay. I guess we got there without this. Let's take a look at the model again. So pretty cool. No divergences. So sorry Lars. This was a pretty easy fit. We don't have any challenges with posterior geometry, unfortunately. Let's go through the Bayesian workflow. So for those who've never seen the Bayesian workflow, I'm going to show it to you real quick. There is a really good graph. So this is the full Bayesian workflow, and it's a good idea to go through this step by step. So we're skipping a little bit here because, again, live stream. But essentially, we should have done a prior predictive distribution, which is very easy in Bambi. We're fitting our model to data. We're evaluating the samples. This is the plot trace, plot rank, all things like that. And then we can go on to the rest of the steps. I'm going to dump this in the chat as well. Actually, and I'll just put this whole chapter in here. So like any good Bayesian, we should check that the things have converged. I'm just gonna do a trace plot. I'm lazy. And here we go. So again, if we look at the trace plot, things look fine. There's two chains. Both chains seem to have about the same kernel density estimate. This one is a little bit wonky. I'm a little suspicious right here because one of the chains happened to get a really smooth sort of skew normal here. This one's bimodal, and this would be something I'd be worried about in an actual problem. What I would do typically is I would run I'd probably run more tuning and more draws just to see whether this chain and this chain tend to converge if there's more samples. I won't do that here again because it'll take a while on this particular computer. But looking at the trace plot, things seem to be okay. So we'll just keep on chugging along. So I'm gonna use the summary function here. And let's see what we get. We get intercept length and our price. So let's check if this is similar to the frequentialist results. I'm actually really curious what it's gonna end up being. So let's pull these up side by side. If I can, let's see if I can pull this off. A lot of screens going on here. Okay, so we have our results here, and then let's find their results. Where did he have it? I should have. Okay, here we go. On the length regression, they got 57. Wow, I mean, damn, look at that. That's actually really good. 57, we got 57. And then, I don't know, is this the intercept? I can't tell. Okay, I probably should have read the book a little bit more, but the slope of the line is 57.20. So, all right, we got that. That looks pretty cool. That's great. Let's do the next regression. Lars, I see your question. I will answer it in a moment once this next model is sampling. And so we want to run a regression on length, weight, headroom, and miles per gallon. So again, we're just going to copy this. Okay. Yeah. I'm going to call this model 2. I'm going to call this 52, just so we don't lose our early results. I will let this run. Okay, great. While this is running, let's look at the comments. Paulo, thank you. You're doing amazing. Thank you, Paulo. This is it's definitely a balancing act. So I'm glad to hear that this is useful and you folks are finding value out of it. I figure this is another way I can get more knowledge out into the world. So people that are doing great work, such as yourselves, are well informed to use all the tools that are out there and knowledge that's out there. So I appreciate you being here. Lars asks, what's the interpretation of RVZ's plot energy function? So let me pull up plot energy while we have a second here. It's a little tricky. I think I'm going to do a poor job explaining it. Essentially, the way plot energy works is it's looking for the energy in what's the best one? In MCMC, there's this concept of energy which is analogous to physics energy, of how the sampler moves from one point to another. I will show you a visual of it so it's a little bit more apparent. And I think if I remember correctly, I think the idea is that the marginal energy should be... All right, admittedly now I'm completely forgetting what the interpretation should be. So what I need to do for you, Lars, is I need to explain how plot energy works. Let me write that down for you. In Lars specifically, I will update the docs. So I will update the docs, and I don't know how I'll let you know, but I guess I'll post in the comments. If you want to be sure that you understand, what I ask is go to Arby's and open up an issue, and just title the issue, title it usage question, and put in just an explanation of what. Please add an explanation of what plot energy does, and we will get that out to you. So it'll be there for everybody, and then you'll be notified because you'll be on the issue ticket. So that will get you your answer. Let us go back to our regression, and I shouldn't have closed that out so quickly. Okay, so we got our fitted model. We got no divergences once again. So unfortunately, Lars, we're 0 for 2 on showing you how to fix posterior geometry. But usually a good thing, but for you, because you need an example, it's not. I wish I could help you out more. Let's go ahead and look at the trace plot, because again, we are good Bayesians. Maximize this real quick. Again, this looks pretty good. Actually, this looks even, well, something. Oh my God. It's because I fitted the other model. All right, we're gonna go through another round of fitting the model. If you're wondering what I was worried about, I was wondering where the other variables are. Yes, we got it. Oh my gosh, how embarrassing. All right, I think like the other models, this is gonna start out a little slow, but then once it picks up, it'll go pretty quickly. This is the Bayesian workflow in action, so I hope you're enjoying it. All right. While we're waiting, any other questions? Happy to keep them coming. What else can I tell you? All right, how does the plot trace look for fat-tailed latent variables? So what plot trace will, let me try and get the 2 points to that. Plot trace is going to, the KDE should look like whatever the final distribution of the posterior geometry should be. So if it happens to be a fat-tailed latent distribution and MCMC sampling went well, then what you will see is a fat-tailed latent distribution, and you should see a long skew. The trace side should look about the same, which is it just looks shaky and things like that. I'm going to point out there's an example in my book, Lars, where I have a fat-tailed latent distribution in this example here with airline flights. So here is the airline delays, and then do I have a trace plot in here? I have a posterior plot, so essentially it's essentially going to be largely the same, but you can see that this is what the distribution would look like with particular likelihoods. So I would go to this example, and it should be a good one for your particular question. Let me pull this up here. Surya asks, is R hat enough? I'm going to answer your question second, Surya, because I'm going to get to the one that just came in. Caleb asks, what kind of sampler does Bambi use? Bambi uses the no U-turn sampler. You can actually see that right here. The Metropolis sampler is not great. I would not advise using the Metropolis sampler if you don't have to, if you can get away with it. It's a Gen 1 sampler. It's pretty slow. You would much rather use an HMC sampler like the no U-turn sampler. HMC stands for Hamiltonian Monte Carlo. So that's the philosophical advice. For practical advice, it automatically uses the no U-turn sampler, which is what PyMC automatically uses, which is frankly, I think, the best sampler out there right now. The team who developed it did a fantastic job. I had promised that I would show you a live sampler earlier, so let me do that really quick. I was a little quick to... I always have to remember the Google search terms to find it. I really want to show you. All right, here we go. This is the one I wanted. So if you're trying to understand what's happening with a sampler, Richard McElrath has a really good blog post where he shows random walk Metropolis Hastings, which is what is being shown here, and then he shows the better samplers, which is the no U-turn sampler, and you can see that happening. Well, this is HMC, but you can see that happening here. So this is how it works. Super cool article. If you folks want me to talk about this more, I can do so at a later point. One other plug I want to give you is, if you're really into samplers, there's another great team working on a super good one here. So this is Blackjack's, and it's a really clean implementation of VI, MCMC, and everything like that. So yeah. That's a sampler question. Caleb says, so no U-turn sampler is a type of HMC sampler, which is why you can talk about energy. Yes, that is exactly the answer to those questions. The energy here is very analogous to potential energy and kinetic energy, which is what's happening here, right? At the bottom of the ramp, this skateboarder has a lot of kinetic energy. At the top of the ramp, they have a lot of potential energy, and those same concepts are the ones that are used to make posterior sampling much better than it ever has been in the past. Lars asks, could you show me where to specify other inference algorithms? Maybe I want to use VI. Yes, Lars, I will get back to your question, but if I forget, remind me. I want to get to Surya's question, which is, isn't R hat enough? Is traceplot a must? So for those who don't know, what Surya is talking about is this thing here. So Surya is asking, is the R hat here enough of a diagnostic metric for convergence of sampling chains than the trace plot? To give you a super quick explanation of what R hat is doing, it's essentially across chains measuring the variance to see whether they're similar or not. It's a very, very rough explanation. I'm going to again plug my book where we explain R hat in much more detail if you want to see that. But the idea is you want this to be as close to 1.0 as possible. And the specific question is R hat enough? This leads to a broader question, which is any diagnostic enough? And I'll turn the full webcam on for a second. Is any diagnostic enough? Can you get away with just trace plots? Can you get away with just rank plots? Can you get away with just effective sample size? Can you get away with just R hat? There's a lot of different, I'd say there's no one correct right answer, but the way I would word it is each one of these diagnostics is testing for a subtly different thing, and they all give you subtly different information. So just like any Bayesian analysis, you want to have a distribution of inputs to whether things are correct or not, and it's the same thing with diagnostics. So for me in particular, this is just my personal preference. I tend to like to use the visual plots as a rough check to see whether everything is going on right, whether that's the trace plot, which I don't use as much anymore actually. I tend to use like rank lines and rank bars. Let me show you rank lines. Rank free lines. So I tend to use these as a visual diagnostic first to see whether things have converged and just double checking here. And then I will use the summary metrics as well, just to ensure that things look all good between the effective sample sizes and R hat as well. So in my personal opinion, Surya, to answer your question directly, R hat is not enough. Just using one number could hide other challenges or divergences or things like that. So I would suggest using 2 or 3 just to double check. And I would use maybe one numerical and one visual. Now the last thing I'll say is that when I run automated jobs where I'm deploying this stuff to like some cloud or I'm running it automatically, you can't automatically check visual plots in an automated pipeline. So what I tend to do is I tend to then, once I'm confident on an initial set of results that it's fine and I want to continue updating automatically each day moving forward, I then just have my deployed environment spit out these metrics, because you can quickly do comparisons against them and divergences as well. Super long answer, Surya, probably a little bit more than you were hoping for, so let me know if you got your answer in all of that. A lot of words there, but quick summary: use a couple diagnostic metrics on top of R hat to check things are going well. Speaking of R hat though, it looks like we got a result, and again they converged. Once again, I apologize, Lars, because you were looking for bad posterior geometry and I don't have it. I just have good posterior geometry, luckily. But let's compare this to the stats model results. So again, the goal of me doing this was to compare this for the book club that I'm running. And what do we have? Hey, the results are again pretty close. 90. Weight is 4.3. Head is 4.9. 490. All right, this is actually really, really close. And you know what's really awesome about Bayesian analysis is you get all the standard deviations here. So we can see that some of these have a larger variance, larger standard deviation than others, but they're well within the range of what the ordinary least squares regression would do, which is super, super cool. Oh, this is really freaking exciting. So I want to show you one other feature of Bambi, which is plot cat. Tomas just merged this. It is really cool. So I've never used it in like a production environment, so let's do that. And then, Caleb, I am going to get to your question, I promise. And Lars had a question, which was getting VI. Okay, we'll do that in a second. So let's go back to GitHub, or the Bambi docs. Actually, they're right here. So let's see if I can figure this out. Let's do some more plots in Bambi. Bambi has a lot of cool plotting functionality, so I want to show that to you. Where's the one that I'm looking for? Sometimes when these libraries have so much functionality, you can't find the one that you're trying to. All right, we're gonna have to do this the other way. We just merged this earlier. plot cap. This is like brand new cutting edge features, so you folks are really getting the latest here. From okay. Let us see. All right, let's try this. I've never used this before in production, so let's see if I can get this working. What do we gotta put in here? Fitted. And then we gotta put in the model, which is just model 2. Always. Sometimes even we just forget. I forget all of my own imports. Sorry about that. There we go. What am I? This should work. I know this should work. Okay, there we go. Yeah, we didn't do horsepower, but we did do, what are the variables we used? We used weight. Let's try it. All right, here we go. Oh, this is so cool. Tomas did such a good job. If you're wondering who it is, Tomas is this guy right here. You should definitely follow him on GitHub. He does really cool stuff. He is, I would call him the lead maintainer of Bambi right now. He is adding tons of new functionality in. He's doing really just a stand-up job getting this functionality out to everyone. So this is great. We can look at marginal effects. Yes. So neat. I'm actually really blown away, as you can tell. Where was our documentation? Yeah, conditional adjusted predictions. So predictions that are conditional on all the other ones. He did the same thing here for the car example that we're on, but you can see what the conditional adjusted expectations are for each one of the variables. Very cool. Somebody had asked, this was I think Haiku had asked, can we get an example with priors in here? Sorry, with manually set priors. Here you go. Here is an example. He's got it right here. He loads in the movie dataset from ggplot, and he uses the normal model, and he sets his own priors rather than setting automatic priors. And here again, you get the conditional adjusted plot from the length of the movies. So, and then whether it's certified fresh or not. And I guess the longer a movie is, people tend to think it's worse and worse, I suppose. Once you condition on everything. So here it is conditioned on a categorical variable as well. All right. Well, with that, we've done everything. Actually, this is a very successful live stream, I might say. Let me see if I can get this uploaded to y'all. Maybe I have it. I guess I have not configured my Git here yet. So I will configure my Git and I will get this out to you folks. I think what I can do right now, let me do this real quick so you have something and you're not left empty-handed. I can, oops. I can do this. I always forget how to use VS Code sometimes. All right, well, I'm trying to get this in actual, I want to see the actual code. I don't want to see the, I don't want to see the relative thing. All right, we'll figure that out later too. This is a whole thing. What is this called? Bambi regression. Yeah, this is okay. I will upload this later, and I will get this to you very shortly after this live stream. Just check the comments. I'll get my Git working. I have nothing left that I need to do on this live stream, so what I'm gonna do now is I'm going to pause here and I'm just gonna answer questions maybe for another 15 minutes or so, whatever folks want. What do you think? I already see a question, so let's just jump to it. Kaikui asks, performance in Bambi in linear regression, it seems slower than running the PyMC equivalent code. What could be the reason prior selection? So the reason it's running slower in this environment that you're seeing here, it's because I'm running this in a virtual machine. So it's not using the full power of an actual desktop, and it doesn't have access to Theano at the time, which made it easier for you to specify math operations in a nicer interface. All it's doing under the hood is using Theano/Asara functions. So my suggestion would be, if you're using things casually and you're just working with them, use pm.math. It's designed as a clean interface. When you need to get to more challenging operations, then using the Asara graph is good. For the last point though, is when you use jax.numpy. With PyMC, and don't quote me on this specifically yet because I'm still not 100% sure, but I'm pretty sure. In PyMC, you're not going to write JAX operations yourself in the model code. You're going to write Asara operations, and what Asara is going to do is it's then going to compile those JAX operations. It's going to compile those Theano operations to JAX. So the idea with PyMC v4 is you write your models. Those models turn into Asara ops. Those Asara ops then get compiled to a backend, which may be JAX, Python backend, although it's slow, and NumPy. And so you specify your models using those interfaces and compile them down. So, third answer, pm.math when you're keeping things simple. I'd say Asara ops when you're doing more and more complicated things, and then you let Asara compile those to JAX ops. Hopefully I got your answer there, Lars. And Lars, you got to let me know, did I miss any of your other questions? I know I did earlier, so just want to double check if I got that answer, and then if you have any others as well. Okay. All right, Lars says I got everything. Fantastic. I will pause here. Let's give this another maybe 15 seconds or so. Maybe a tutorial on stream data would be cool. When you say stream data, do you mean, Lars, that data is coming in real time and that you're updating your posterior in real time? Could you explain that question to me? Look at Lars a second here. Yes, okay, so I can answer this one directly. So Bayesian modeling, when it's done in this style, when it's done with a PPL, is not actually a very good fit for streamed modeling. It would be too slow and too inefficient to have data come in and then update your model like on real-time streaming. Now, how fast could you update this? Like theoretically, you could update this model using MCMC every minute or so, but honestly, I don't think that's super practical. If you do want to use Bayesian analysis though on stream data, let's say like a live A/B test or something like that, I'm gonna keep plugging my book because we wrote a lot on this. You can do that using conjugate models. So we have this section here on near real-time inference, which essentially is streaming. And so in that case, if you wanted to use a Bayesian model, I would suggest using something like a conjugate model or even a faster inference method, maybe like Laplace approximation or something. So then you can get models in real time. So you can get posterior results in real time. Now there's one other thing, Lars, I just realized that you would ask for, and it's how do you do VI with PyMC? I don't know how you do VI with Bambi, I'll be honest. I will take that as a second question that I will come back and post in the comments. But I will show you how to do that in PyMC. So let me write that down so I don't forget. But let me show you the VI interface in PyMC. So this is the PyMC 3 variational inference. So quick note, we have PyMC 3 is the older version of PyMC now, and PyMC is the newer version. But here is the guide for VI. If you're going to specify a model, you can see things look a little bit different because it's a VI model, it's not an MCMC model. But this will give you a sense of how to run VI using the PyMC model definition. And I will go and double check how we can do that with Bambi. A kind of a trick I just want you to know is you can specify a model in Bambi and then extract the specified PyMC model and then use VI to fit it. I'm not going to show that here. It's a little bit more of an advanced trick, but the short again answer is VI is available and it's really great for particular models. So now you've seen it. Any other questions? Lars, I've been loving, you've been really engaged this whole live stream, which is awesome. Anything else? All right, going once, going twice. I'll count that as nothing. If you have any more questions, just leave them in the comments or message me on Twitter. You probably found me there already, but you can find me at this place. So there's that. And then if you're interested in this sort of stuff, we're gonna be sending out, as you can tell, we're really great about learning. We love people learning and things like that. So if you want to join the mailing list, you can, and we'll send out content this way as well, trying all sorts of formats to get as much out there as we can. So thank you, folks. Enjoy your evenings and your Mondays, and I hope to see you on a future live stream. All right. See y'all.